The salt brine process. The price of granular salt has gone up 167% in the past 20 years. $1,000 worth of salt in granular form is enough to clear 86 lane miles. Mixed into brine, it can clear 224 lane miles without compromising public safety. How brine is made. Rock salt, sodium chloride, is transported by skid steer from the salt dome to the brine room. Approximately 2 pounds of salt will make 1 gallon of salt brine. This 1 bucket of salt, 2,000 pounds, will make about 1,000 gallons of salt brine. The salt is then dumped into a large hopper, where a spray bar on the bottom of the hopper dissolves the salt with water. As the salt dissolves in the top hopper, it's pumped down to a lower reservoir. The brine in the bottom reservoir reads approximately 24 to 25% salinity. Once the brine reaches 24 to 25% salinity, it is pumped out of the lower tank to the main computer station. At the computer, salinity readings are taken and a small amount of fresh water is added to reach the desired 23.3% salinity. 23.3% is needed to keep the salt stable and suspended in the water. A reading of 24.4% in the lower holding reservoir means it must be diluted to reach 23.3%. Fresh water is then mixed in to reduce the salinity to 23.3%. A reading is then taken as it's pumped to the holding tanks. The brine system can make up to 90 gallons per minute or 5,000 gallons per hour. A manual reading is then taken with a salinometer to verify the computer is diluting the brine properly to 23.3%. After the brine reaches 23.3% salinity, it's pumped into 5 holding tanks. The 6th tank pictured is for calcium chloride to blend in when temperatures are extremely cold. The brine is then pumped into the truck at 150 gallons per minute or 300 gallons per minute on the high flow system. This particular truck is capable of holding 800 gallons of brine. This truck is also able to hold and apply rock salt in addition to the salt brine. Getting the salt and brine on the road. Rock salt is fed through a series of augers down into a hopper. After the salt drops into the hopper, a series of paddles throw the salt onto the road at the approximate speed of the truck. The salt is then sprayed with salt brine before being discharged from the paddles. This process is called pre-wetting. This truck can apply 60 gallons of salt brine per ton of salt. Salt and brine is then thrown to the top side of curves. As the salt and brine melts the snow, it becomes more brine and runs down to the bottom side of the curve, melting more snow. The same principle is used on a typical section of road. Salt is placed on the center line so it's less likely to be blown off by vehicles, as well as it uses the slope of the road as the snow and ice melts. Pre-wetting salt keeps more granular salt on the roadway by not allowing it to bounce as much as dry salt. This keeps an estimated 30% more salt on the roadway. Anti-icing, the preparation before the storm. Up to 48 hours before the storm, high-traffic roads and problem areas are sprayed with salt brine through a spray bar. This process is called anti-icing. 8 nozzles, spaced 13 inches apart, spray salt brine at up to 60 gallons per lane mile. Anti-icing will melt some snow to provide additional time for crews to get out and apply more salt. The most important benefit to anti-icing is not allowing the snow to bond to the pavement. Anti-icing is the equivalent to greasing a frying pan before cooking. You can see the difference in lanes that have been anti-iced. The right lane has had the 23.3% salt brine solution applied to the road. The left lane hasn't been treated. This picture shows the melting ability of salt brine, but more importantly, not allowing the snow to bond to the pavement. This in turn creates better driving conditions for motorists, more economical use of granular salt, and less of an environmental impact.